Good morning, everyone. Welcome to this morning's panel. For those that have not had the privilege of meeting before, my name is Bill Rosehart, and I'm the Dean of the Schulich School of Engineering. We are excited to have you here to discuss one of the University of Calgary's less known research strengths, rocket science. We are very proud of the game-changing aerospace engineering research and development taking place at the University of Calgary. Before we get started, I'd like to acknowledge that the University of Calgary is on the traditional territories of the people of Treaty 7 region in southern Alberta. The city of Calgary is also home to Métis Nation of Alberta, Region 3. A few housekeeping items. We are using a Zoom webinar software that places attendees on mute automatically and doesn't share your video. So no worries about mistakenly interrupting the session as you watch. We'll be holding a question and answer at the end of the session. So please use the Zoom Q&A function to ask your questions and feel free to post them throughout the panel discussion. Before we launch the panel discussion, I have to have a few launch and rocket jokes as we go. I'd like to tell you a little bit about the Schulich School of Engineering's new minor in aerospace engineering. This minor enables our students to design and construct new aircraft and spacecraft systems, such as crewless aerial vehicles, flight control systems, propulsion technologies, satellite technologies, and navigation and remote sensing systems. A number of Schulich engineering professors and grad students have been busy out at the Rothny Aerophysical Observatory testing new, greener rocket fuels and lighter rocket engines. The group has also launched its own rocket at a nearby Canadian Forces base. Check out this CBC News story on their testing and flights.
Canada, this is really the biggest rocket research program that's being done at a university on a fundamental level. But even just in general, developing new kind of rocket motors, high-speed vehicles, all of that stuff is really only happening at the University of Calgary in terms of building, designing, and flying vehicles.
2, 1.
We have flown 3 times with this rocket motor and the vehicle. For a long time, people thought that rocket technology was mature, but the type of rocket motor that we're looking at is a different type of motor. And in the scientific literature, that is one that's receiving a lot of attention.
The most novel aspect of the rocket that we're developing is the fuel. So hybrid rockets have actually been around for a long time, but they've kind of always been overlooked. They didn't scale well, so it was hard to get a lot of thrust out of a motor. So the fuel that we're developing is actually going to solve that issue because it's a much higher burning rate than you get with more traditional fuels. So this is a hybrid rocket motor. And so what it consists of is propellants in 2 states of matter. So back behind the steel plate here, we have a tank, and that holds a liquid oxidizer. In our case, it's nitrous oxide. And then in this chamber here, which is also the combustion chamber, we have a solid fuel, which is a wax-based, paraffin wax-based propellant. And so what we're interested in here for the research we're doing is really how this fuel inside the combustion chamber is performing. It's a lot safer to develop than some of the alternative rocket systems out there. And because it's safer, it generally means that it's lower cost.
This is high-tech work. The skills that the students learn are very relevant to a lot of different industries. They're learning how to program, they're learning how to do computer simulations, they're learning how to run very intricate tests. They'll be very marketable and useful for all sorts of industries in Alberta. But in terms of aerospace itself, and that's going to be a growing industry, and the global space economy is going to be growing as well. And thinking big, it would be nice if this was the beginning of maybe a launch vehicle that was developed in Canada, designed by Canadians, launched from Canadian soil, which is something that we don't have right now.
Now it's my pleasure to introduce today's panel members, and I'll get the panel members to put their cameras on so they can join us here now. First, we have Dr. Craig Johansson, a faculty member in our Mechanical and Manufacturing Engineering Department. He also holds the Schulich School of Engineering Research Chair in Aerospace Engineering. Dr. Artem Korobenko works closely with Craig to establish the University of Calgary Aerospace Network. He is also a faculty member in our Mechanical and Manufacturing Engineering Department here at the Schulich School of Engineering. Vlad Moravchuk is Chair and CEO of Atlantis Research Labs Incorporated, a privately held innovation company developing advanced energy and aerospace technology. And finally, Adam Trumpor is a rocket and gas turbine propulsion professional who works with Pratt & Whitney Canada. He is also a founding partner in Continuum Aerospace, a small company that develops innovative rocket propulsion systems. So thank you all for agreeing to be here today and bring your expertise to this conversation. So to get things started, can each of you spend a minute or two telling us about what role you play in this growing economic sector, aerospace engineering? Craig, maybe we'll start with you.
Great. Thank you, Bill, for introduction there. So as you have said, we are part of the University of Calgary Aerospace Network, doing aerospace research at the university, covering a lot of different areas. And my role is mainly in the high-speed aerodynamics and propulsion part of the research. And as shown in that CBC article, one of the areas that we work on is rocket technology and developing different vehicles and testing them in test ranges in Alberta. I believe my colleague, Dr. Korobenko, has a bit of a presentation that kind of covers all the different areas of the University Calgary Aerospace Network and how it all fits together in the big picture for aerospace research here.
So we'll move it over to you, Artem.
Thank you, Bill. Thank you, Craig. Yeah, so as Bill introduced, I'm an assistant professor at Mechanical and Manufacturing Engineering. I'm the current director of the University of Calgary Aerospace Network. Craig was the former director. So my role in that area is primarily developing the advanced numerical techniques to enable the simulation of the complex airspace systems, again, together with the industries, national labs, and other institutions. I think I will have the room later on to show the presentation. Am I right, or is better to step in right now?
Go ahead, Artem.
Okay, great. So let me share that. Okay, I hope everybody can see this, and there is no screen blocker or anything. So the University of Calgary Aerospace Network was formed about a year and a half, roughly, I would say, with the group of faculty members. Currently, we're about 40 plus people from the Faculty of Engineering, Science, and Business working in the aerospace-related areas. We are sharing the world-class research expertise in areas such as aerodynamics and propulsion, flight research experiments, flight dynamics and control, multi-sensor and avionics, diagnostic, navigation, positioning, image processing, robotics and autonomous vehicles, materials and manufacturing, advanced numerical methods, big data, machine learning, AI, and also a big part of the space systems with the instrumentation and measurement. So that's just to mention a few. We are positioned in a great place in Alberta. We are in the close proximity to world-class flight test ranges, such as two military bases, one in the Cold Lake, one in the Suffield, as well as the foremost US test ranges, as well as the within the city, we have the Calgary Living Labs, where you can go and you can test your different concept for the unmanned vehicles. We also have a strong group of students who are working in the aerospace field. Currently, we are about 200 plus students in the undergrad level, working with the different student clubs. Here we have a few mentioned. As Bill mentioned, in this fall, we are in the intake of the newly formed minor in the aerospace engineering, which shares between several departments within the School of Engineering. I will also pass it maybe back to Craig, just also say a few words about the rocket part of the aerospace. Craig?
Yeah, just in the following slide, there's a video that just has the rocket launch, which was shown in the CBC article, but this is a different view. And this is just something between the student clubs, Atlantis Research Labs, and our research group.
Yeah, so I'll just finish that up, and then we will ready for takeoff. Great, thanks.
Thank you, Artem. Maybe over to you, Vlad. Could you take a few minutes to tell us some of the exciting things that you're doing in this sector?
Sure. So I'm the chairman of Atlantis Research Labs and Avro Aerospace. I've been involved with Professor Johansson and the University of Calgary for approximately 8 years. We're a proud sponsor of the activities there at the lab, at the Raptor Lab, and on some innovative jet propulsion work that's happening there. Avro Aerospace is focused on delivering solutions to private industry and government clients in terms of unmanned systems and some of the new capabilities they're looking at here in the 21st century for defense needs, for search and rescue, and other geomapping and other applications they're using unmanned systems for. So we're a proud sponsor of the activities there at the lab. We employ 20 people at our end. We provide innovation services to, as I said, defense, industrial, military clients globally. And we have a number of engineers that are working at a long-term program in partnership with the university to deploy a set of air vehicles, not only for Canadian use, but for international use. So in addition to the test vehicles at the university, we're complementing the activities by commercializing those vehicles. So you'll be seeing those vehicles in the sky fairly soon. Thank
you, Vlad. What about you, Adam? Could you take a minute or two just to introduce some of the things that you're working on?
Absolutely. So I wear a number of different hats these days. So by day, I work at Pratt & Whitney Canada in the Toronto area, where I'm a concept designer and design integrator for aircraft turbine engines. And so that occupies the daylight hours, and during every other waking moment, I'm heavily involved in rocketry and advancing the cause of entrepreneurial space and rocketry within Canada. So I years ago kind of concluded that if I was interested in getting my hands dirty and learning rocket technology in a serious way in Canada, where this has not traditionally been among our technology niche areas, I was just going to have to do it myself. So for a number of years, I've worked on designing, building, and testing fairly large liquid and hybrid rocket engines, and built up a pretty significant rocket propulsion R&D capability. For a while, doing this, felt like being a bit of a cry in the wilderness, but over the last several years, there have been some pretty impressive changes to the scene internationally and within Canada. A big part of that has coincided with the rise of these student rocket teams. So we're now at the point where there are something like 20 major university rocket teams right across the country. And having built up this skill set that's not real common in this country, I found myself mentoring many of the more advanced teams, particularly the ones that start getting into propulsion projects. So I spent a lot of time helping teach them how to not blow themselves up when working with these kinds of things. And I recently started a not-for-profit called Launch Canada that's actually working now to set up the first ever major rocket engineering competition in the country to give these students an outlet to be able to really run with their activities here and create more visibility for it. And at the same time, we're trying to become an umbrella organization to make sure that any Canadian students who feel drawn to this area and want to get involved have the opportunity to do so and the chance to connect to the resources they need to be safe and successful.
Thank you, Adam. To all our panel members, and several of you touched on this, is, we've heard Calgary economic development and other economic development areas identify the aerospace sector as an important emerging area. It certainly is here in Calgary. Just how much aerospace research, development, and commercialization is happening here and in the rest of the country now? And what do you expect to happen in the next couple of years? Who wants to take that one first?
I can probably start with that one. So as I previously briefly mentioned, we do have a critical mass of people on the academia side, on the student side, as well as on the industry side. So in addition to the initiative within the Calgary as well as Alberta related to the aerospace, I will just give one brief example. We do have two major aerospace contractor having their Canadian headquarters in Calgary. That includes Peraton and the Raytheon Technologies. That's just the currently biggest aerospace companies. In addition to all of the SMEs, which are really pushing the boundaries of the aerospace, like Atlantis Research Labs and other. I will then probably pass it to Craig to add.
Sure. In the broader scheme, Canada has always had a pretty strong history in aerospace. A lot of famous examples come to mind. Probably the Avro program, which Atlantis Research Lab has one of their division names now, was a really famous aerospace program that had the most sophisticated supersonic fighter jet of the time in the world. So that was a real sense of national pride for the country. And shows that we can do really world-class innovation work, in Canada. And of course, in Canada we have the space robotics. We have a lot of good work in civil aviation. I think one of the key parts of Alberta that I think will grow in the future is the access to all of our good test ranges. And the companies here in Alberta that are developing the technologies, they can test them at these test ranges. So I see a bright future for this kind of aerospace in this part of the country.
Adam, do you want to add to that?
Yeah, absolutely. I think that this is actually an incredibly exciting time for aerospace in Canada. We've always been pretty heavily involved in aviation and space, really going back to the very beginning. But in the past, it's tended to, first of all, be a very regional thing that tended to focus on the Montreal and Toronto areas. And it's also tended to be very focused on specific niches. So obviously things like space robotics, remote sensing, these are areas that we've traditionally been really strong in. But we have often had this kind of zero-sum game mentality in the past that says, we've got to stick to the things we're good at, and we couldn't possibly branch out beyond that because we have a limited number of resources that we can put towards it. That's been starting to change in a number of really impressive ways. We've started to see regional barriers breaking down. And I think the rise of this industry in Alberta is a really good example. Particularly, when it comes to things like test ranges, as Craig mentioned, there aren't a lot of places in Canada where you have the sort of big, wide open, flat areas that you need if you're going to be launching things. But Alberta is the prime location for a lot of that. We've also started to see a realization that we don't actually have to be limited, or we don't have to limit ourselves to doing more of the same things that we've done before. And rocketry is, I think, one of the best examples of that in recent times. This younger generation has been coming of age watching private companies like SpaceX do things that in the past were thought to be, solely the domain of major, national governments. And the cool thing is, once you realize that a thing is possible, you can't really go back. You cannot unsee that. And so the student rocketry movement has really sprung from a lot of that. They're seeing what's going on. They want to take part. And they're increasingly saying, well, why can't we? And taking it upon themselves to do it themselves. So we're seeing the growth of an entire new aerospace ecosystem in the country, and I think it's really exciting.
That's great. Vlad, industry academic partnerships are a really important part of advancing new technologies. Could you tell us a little bit about what Atlantis Research Labs has been doing in terms of partnerships with the University of Calgary?
Yeah, certainly. Professor Johansson and I first started by engaging the National Science Engineers Research Council through a smaller program, which allowed us to set the foundation for the initial propulsion research that the University of Calgary is now excelling at and becoming a world leader at. So there are frameworks within Canada that allow good ideas and academic researchers and private industry validations and challenges to come together and create new value. Really, technology is, the ability to be faster than other nations and leveraging the abilities of academia and the private sector really is the best deterrent in the 21st century in terms of national security and achieving some of the goals within the industrial landscape that exist in Canadian aerospace and where we want to go from a national leadership position. And there needs to be a major modernization in Canada of our infrastructure, both on the defense and the private side. And, one of the things Ottawa identified in Ottawa was that to better leverage the private academic partnerships that are available in Canada. Now, University of Calgary is very unique ecosystem, and you're going to see a lot more private leadership and industry stepping into the University of Calgary. They have a very favorable environment for collaboration with industry, allowing the intellectual property to remain with the companies that pay for patenting and for technology development. And so that allows us to hire out of the programs directly into our company. We've got a number of examples of U of C alumni coming through Atlantis and being employed with us. So there's a number of ways we can continue to collaborate with industry. It's been a very successful model to date. And, we've got great communication with the U of C. So it's, I think it's a framework for the future in Canada here, whether it's at Ryerson, but specifically at the U of C because of its unique industry structure, how it partners with industry. I think U of C is going to be a leader. So for anyone looking at where to go in Canada for advanced aerospace, I believe University of Calgary is going to continue to emerge as a national leader here.
Thank you, Vlad. Thank you for the plug too. Adam, in your opening remarks, you talked a little bit about the impact that more student teams in the aerospace is having on the sector as a whole, and you also talked about starting Launch Canada. And I just wondered if you could elaborate a little bit on what do competitions like Launch Canada, what do these student competitive teams do in terms of a catalyst to really move the industry to the next level?
Absolutely. So, I mean, the greatest thing about the student rocketry aspect is that it's almost the definition of a grassroots movement. Historically, space has tended to develop very closely along the traditional defense contracting model, where it's really top down. You know, government is the customer, and government needs drive the priorities for contractors, who then develop technology to meet those needs. And we've gotten used to thinking that space works in that same way. What we're seeing now with rocketry is an example of a bottom-up approach. You know, at no point has any Canadian government ever formally stated that space launch is a critical capability that the country wants to have. But a lot of students are realizing the potential of it and choosing to do it anyway. And that was my rationale for taking, let's say, the amateur rocketry approach. But for a long time, for students, you know, there was no obvious way to get involved in this in Canada if they found that this is where their interests lay. It was actually a competition in the United States called the Spaceport America Cup that gave Canadian students the first real concrete outlet to be able to pursue advanced rocket projects. And this started about 7 or 8 years ago with a couple teams in the Montreal and Toronto areas. And since that time, it spread nationwide. And the Canadians have consistently done disproportionately amazing at that competition. You know, 2 years ago, the Canadians made up about 10% of the teams there. Most, as you might expect, were Americans. The Canadians won 3/4 of the awards at the entire competition, including first place overall. And they placed first in every category that they took part in. So for the awards ceremony, the podium was full of Canadians. They pulled out a flag and started singing the national anthem while the CEO of Spaceport America looked deeply uncomfortable watching this. And so it's been this remarkable success story. But the challenge has been that then they come back home to a country where, you know, there is no Canadian SpaceX. So that traditional approach of getting a degree, getting a job in your chosen field hasn't really existed for them. But there's been a growing interest in changing that. And we now actually have several new startup companies that are working towards Canadian launch capability. And every one of them was either founded by ex-student rocket team members or else hires almost exclusively from ex-student rocket team members, because right now, that's the talent pipeline in Canada. You know, rocketry is one of these areas where there is an enormous gulf between the theoretical and the practical. And so to develop the real world skills you need to be successful at this, there's really no alternative but to actually go out and start doing it. And the rocket competitions have provided students a way to do that. What we're trying to do with Launch Canada is make this possible within Canada so that teams don't have to leave the country to do these things. And at the same time, we're realizing that support for this stuff is very uneven. You know, not a lot of people happen to be in areas where they've got access to expertise. So with Launch Canada, we're really trying to become an umbrella organization to support this in like really right across the board, from opportunities to launch to opportunities for mentorship, connecting with safety standards, all of these things. So it's really a way to empower these really enthusiastic, motivated Canadians to be able to follow that and pursue it, hopefully as far as they can.
Thank you, Adam. One of the questions that came up in the Q&A relates to an earlier comment about the Canadian Avro rocket project. And the first question is, was there an agreement put in place at the time that prevented Canada from building an aircraft like the Avro Aero again? And if there was an agreement, is that agreement still in place?
Well, I think I'll let Vlad mention this a bit, but as far as I know, you know, we can continue to develop that kind of stuff, but you know that the politics at the time were definitely different than what the politics are right now in terms of Canada's relationship with the U.S. around aerospace development. But I'm sure Vlad knows much more about this area.
Yeah, we acquired Avro Aircraft Limited and Avro Aerospace from the Canadian government in 2010, and we received clearance to do that. And we looked at it, and there was no legal framework or legal restrictions on how we could use that name, where we could go, where we could develop it. Coincidentally, as Adam was saying, there's a contest in New Mexico held at Spaceport America, which we attended. We brought several of the Avro engines down without any challenges, other than having a bit of a fun time at the border for 8 hours with that. But other than that, Avro is fully cleared to continue to aerospace development. Historically, the most advanced interceptor we created in the 1950s that the Diefenbaker government decided to axe had several reasons why it was discontinued, including fiscal ones. So there was never really a restriction put on Canada supplying or building this kind of equipment. There was just a meeting that occurred between political figures that essentially ceased production of that Canadian interceptor, and the prototypes were subsequently scrapped. But as it stands, the 21st century version of Avro, we want to do a really significant program with this. Adam started to talk about the basics, for example, sponsorship in student academic rocket programs. But ultimately, the goal of Avro is to be a source of pride for Canadians again, and we want to do Canada's first orbital launch from Canadian soil. You know, I'm maybe sharing a bit too much, Craig, but there's a few thing we intend to do with the Avro brand to be a source of pride, because it is a valuable Canadian heritage aerospace brand. We want to do it justice.
Thank you, Vlad. And maybe for all the panelists now, when we're thinking about looking to the future, what do we need to do to advance aerospace engineering in Canada moving forward to really take it up to the next level?
I can
maybe we'll start with Artem.
Yeah, thanks, Bill. Support. So continuous support on the different levels, right? Also, like, I'm not only speaking about the governmental support on provincial and federal level, but also the support from the community, because as Adam mentioned, you know, we also need to change the mentality in some way that there is an aerospace in Western Canada, specifically there is an aerospace in Alberta, and we are not a traditional aerospace. We're really pushing the boundaries to the next level, the advanced aerospace technologies. So maybe Craig can add something on that as well.
Yeah, and I think going forward, one thing that we can do to really advance aerospace in Alberta is to gel together into some kind of hub or cluster of companies, universities, and government organizations, and really have the niche of, you know, the high-speed vehicle development, things like rockets and high-speed UAVs, and have them tested and built here. So there's kind of a more permanent presence of that kind of work, and attract people from around the country and the world that, you know, if you want to do this type of aerospace, this is really where things are happening.
Great, thank you. Before I start to dive into the Q&A coming from our audience today, and again, the Q&A is open, please post your questions and we'll get to as many as possible. Let me just ask this last question from myself. Nothing says dream big, you know, like space travel, like rockets. Maybe each of the panel members, could you just quickly tell us what's your big dream for new futuristic aerospace technology? Maybe we'll start with you, Vlad.
Well, I can speak to a few of the things underway at the U of C, and briefly speak about some exciting technology at a high level at the company that I'm working at. But we see Calgary as the corridor to the north. So there's a number of initiatives underway in Canada to develop our Canadian northern regions, more from a resource development and also from a sovereignty perspective. And so new technologies are being developed right here at the University of Calgary. I'm proud to say that we've developed a jet engine with no moving parts that's extremely valuable for the aerospace sector globally right here in Calgary. And Professor Johansson and his team will be conducting live fire testing of that engine here towards the end of the year and into the new year. So that's a big milestone for global aerospace. In addition to that, there's some novel work happening in hybrid rocket technology, and a number of patents and new intellectual property is being developed as a result of this. And what these capabilities do is they really enable simple, low-cost access to space. And I think this is where Canada, specifically Calgary, is going to become a global leader, is low-cost access to space. And all of the pieces that were mentioned previously here, such as our excellent military bases, our excellent testing facilities that we have in Alberta, allow us to really build up that infrastructure that's going to be required to develop Northern Canada. Northern Canada is the largest opportunity in the world, the largest geopolitically uncontested region in the world. And Canada has big plans to do an audit of all its natural resources using unmanned systems. So I think just regionally here, aerospace is going to become one of the largest industries in Canada. And further to that, our technical leadership in actually developing new technologies, new safer ways and cheaper ways to access space and high-speed realm are critical. And just, Craig, to the point that you had made about industry collaboration, we did form a consortium here in the West called the Supersonic Autonomous Systems Consortium. It's a mouthful, but it involves industry partners like Raytheon. We've approached the University of Calgary and a number of other private companies here in Alberta. So we are starting to cluster together and pool capital, economic development capital. And I'm also, I didn't mention that University of Calgary is the proud recipient of the largest CRD awarded in Canadian history from the National Science Engineers Research Council. So there is additional federal, provincial, and industry money coming to Alberta, pooling together, and we're forming a corridor to the north using advanced technologies developed here. So it's an exciting time.
Yeah, I think, economies do change and evolve over time. But one of the greatest things about space is it is pretty much the definition of a future-proof industry. Space is incredibly important to Canada in a lot of ways that many people don't even appreciate. And it's only becoming more so going forward. What's finally starting to happen, and what I think is my biggest hope for the future here, is that this new trend of branching out beyond our traditional niche areas will continue. We've always had this really self-limiting approach for a very long time. That's tended to fixate on doing more of the same, more of the things that we've been good at in the past. The problem when you do that is you fail to appreciate changing conditions. You don't do anything new, and sooner or later you find that the things you were once good at are no longer in demand in the way they once were. If you look back to the early 1970s, there weren't many people who foresaw the way the personal computer would come to change everything about how we work, how we interact with each other. But some people did. And generally the people that did were the amateurs and hobbyists in places like Palo Alto. They saw the potential of this when many people did not. And they went on to start, little companies like Apple. And we all know how that went. We need to try to set up an environment where people who are, similarly passionate about areas of technology, even if they are outside the norm for Canada or for a region of Canada, have a basic level of support available so that they can run with those ideas and see how far they can take it and have the learning experience that goes with that. If you look at a place like Silicon Valley, that's why Silicon Valley works. It's a place where people with a big idea can find fairly easily a basic level of support to pursue that. And hopefully that'll turn into much bigger things. If it doesn't, it'll turn into an incredible learning opportunity that will lead them to doing something else that might pan out in a big way down the road. So I think that we need to move in that direction in Canada, and if we can do that, I think that we're heading into a really exciting time.
Artem, Craig, dream big. What's some of the big things that you can speak to that's on the horizon?
Yeah, I'll start. We, as Craig mentioned, and I'll follow up on that, we definitely, building on the capabilities we have and the potential we have, is we really want to be a hub for the aerospace, not only in Western Canada, but also, nationally, and attract the, our partners worldwide. Now, that doesn't mean the traditional aerospace, okay? I mean the next generation high-speed air systems, including the high-speed autonomous systems, that really pushing the boundaries to the next level. And, if we want to be, competitive within the next 5 years, that's what we start to invest in right now. Craig?
Yeah, and I would say, just to be a little fun about, what's the dream big technology? I think the holy grail for like in the area of high-speed aero and propulsion would be a lifting body autonomous vehicle that takes off from a runway and delivers a small satellite into space, because it has the propulsion to go all the way up to the atmosphere and into space, and then come back and land on the runway. And it's been something that people have been trying to do for a long time, but with the autonomous systems becoming a bigger thing, and the ability to make smaller vehicles that don't cost so much and they don't risk people's lives when you're testing them, I think this could be very exciting, and definitely one of my biggest dreams for the long run.
Craig, is it going to land at the Calgary International Airport?
Well, hopefully it'll be nice and quiet, and you won't even know what's happening. And it's not a big noisy rocket. It's just quiet airplane. So that would be nice. I would like to take a trip.
We have a number of questions in, and that's great. Thank you for the people attending today. There's a set of them around some of the student activities that are happening. And so maybe I'll just run through a few of those first. First one might be an easy one to Artem. How long has the aerospace engineering minor been offered at the University of Calgary?
Yeah, so the official intake of the minor is fall 2020. So that's a short answer.
No, that's great. And switching now on the graduate side, if you're a graduate student, we have some people joining us today from around the world. And the question is, if you're an international graduate student or want to be a graduate student at the University of Calgary and work in aerospace engineering, how do you make that happen?
Well, that's a great thing for us. We are always looking for new students, and it doesn't have to be a Canadian student. We're really looking for very talented international students. And it's as simple as just contacting us individually, or there's also a University of Calgary Aerospace website that has a contact, general contact, aerospace at ucalgary.ca. And just let us know what kind of research you would like to work on as a graduate student, and and a bit of a background of yourself. But there's a shortage on our side. We need to hire a lot more than we can find. So we're really excited to talk to anyone that's interested in this kind of work.
And Craig, maybe a good follow-up to that question is, we have actually some of our first-year students listening to the presentation, and one wants to get involved in aerospace research. And what's the best thing that they could do to help make that happen?
Well, I would say first, make sure you're doing a good job with your schooling so that you have good marks and you're taking care of that. I'd say join the student clubs. I'm a very big supporter of them, like the SOAR Club, which is our rocket team, which competes in Spaceport America. I think it's one of the best experiences you can have, is working on these kind of teams and these hard projects. And if you want to be involved in the research side, there's a lot of programs to get involved. Like there's a PURE and the NSERC USRA programs that support, a summer program where you can work in one of the labs. And again, it's contacting the individual professors or contacting the department and just trying to see is what you want to do match up with what is available, and it probably will be. So just reach out.
Thank you, Craig. Diversity is a really important thing, and embracing and supporting diversity in engineering is core to the Schulich School of Engineering. And Artem, I'm just wondering if you could speak a little bit to diversity in the aerospace sector and in the work that we're doing at the University of Calgary.
Definitely, Bill. I mean, that's a very important question, and I know Adam will probably follow up with more examples from the students clubs he's working with. But so one thing to mention, within all STEM disciplines, aerospace has the largest percentage of the women participants. Okay, that's one to mention. If we go down to the student clubs, and the question I think was related to like what's the percentage of girls and boys in the student clubs and the disciplines is. So those students clubs are very diverse, and one worth to mention is that the former lad of the SOAR club was a female student, right? And there is an amazing number of examples where, the female students took a certain administrative and lab position, and then they continue working in organizations like CSA, NASA, and so on. So I think we are working on that to make sure we increase the participation, not only of the female students, but also the underrepresented group. And I think Adam may probably follow up on that as well.
Yeah, absolutely. And I mean, first, I fully acknowledge the irony of a panel of white guys talking about diversity and inclusion in aerospace. But I will say that there really is, I think, a very diverse crowd involved in this. As Artem was saying, there's probably one of the highest percentages of females involved in aerospace than any of the engineering disciplines. With the Launch Canada teams, we're finding it's probably about 30% female or so. And we've got, I think, about 50% visible minorities taking part as well. So that there is a really universal draw, I think, to this industry. It's clear that we need to be doing more to to try to reach out to people who are maybe less represented in this area and make sure that they feel comfortable. But there is no question that this is an industry where diversity is really important, and diversity of thought tends to come from diversity of background. These things do correlate, and in aerospace, a lot of being safe and successful at it is ultimately a question of imagination. You've got to try to foresee things, understand ways in which things could fail or things could play out, and getting a diversity of opinions help you a lot in doing that. So there are real benefits to this in a purely pragmatic sense. I think we're seeing that there's the passion for these things is pretty universal, and that's a really good thing. And so I think everything that we can do to try to make sure that people feel like if this is where their interests lie, they have the ability to take part is going to be really important.
Thank you. Switching gears a little bit in the questions, if you're working right now, but not in the aerospace industry, that's not your background. It's really exciting that we have the minor and team, but you've already done your engineering training and you're in the workforce, and you want to transition into working in the aerospace industry. What advice would you give somebody who wants to transition their career into this exciting field?
I can answer that. I would say you probably have a lot of the skills that already overlap with the aerospace industry. Let's say you're someone in Alberta that is in the energy sector. That's a very heavily overlapped area with aerospace. A lot of this, what you would learn to become that kind of professional, you'll also learn to become an aerospace professional. There's probably some key areas that need to get trained on. So, a graduate program or an MEng program would be something that you could do, but also just collaborating, with the industry that's already here, or the research programs as well could give some of that experience. But I would say the biggest thing is don't count yourself out because you're in one industry that you can't switch to another. I think they're actually a lot closer than everyone thinks.
Absolutely. To add to that, I think space is incredibly multidisciplinary, and rocketry, even more so. That's always been one of its great strengths. There's almost no area of engineering and technology that doesn't come into play in some way. So you might actually be surprised. You might find that you've got more of the skills that you need to be successful than you imagine. But the one thing that almost everyone in this industry will say is that they have a real passion for it, and that's what draws them to it. So for myself, I focus a lot on what is often termed amateur rocketry, but I mean amateur in the original French sense of the word, one who does a thing for the love of it. They may hope to one day make money at it, but that's not primarily why they're doing it. Maybe they've always been captivated by space, and like the original pioneers of the space age, we're particularly intrigued by these extreme machines required to make that possible. Or they watched that magnificent simultaneous landing of 2 Falcon Heavy boosters at the Cape and thought, wow, that is the most sci-fi thing I've ever seen in my life. I want to learn about the technology that did that. One of the most talented rocket propellant professionals I ever met didn't actually have an engineering degree. He had a degree in music. He taught himself as an amateur rocketeer because it captivated him, and he became incredibly good at it. So I think that if you find yourself drawn to this in a similar way, you can do it. You really can. And with Launch Canada, a big part of why that exists is to make sure that people like that, who do feel the attraction to it, have the opportunity to get involved.
If you're at the University of Calgary and you're a student, to join SOAR or one of the other teams, or sign up to take the minor. If you're already out in the community, a practicing engineer, and you want to get connected to the community, what are some of the best links and organizations for individuals to start following in the Calgary and the Alberta area?
Well, if you're specifically interested in the rocket area, I would say the local rocket association, the CRA, would be a good option. They do some pretty impressive work, some high-powered rocket launches. It's more, again, the love of rocketry, and it's personally funded things that people are doing. But that we work closely with them. A lot of the SOAR members, work with them. We have the CRA people come and assess our rocket designs. So I think that would be a great way to get involved with the community for that side.
That's great. As we talked about aerospace and rockets being, moving forward in terms of the economic impact, what's the role that the Alberta government's had and might have in the future to be involved in supporting this industry?
I can, or maybe Vlad, you can start from the industry perspective.
I've worked with some of the members at the Alberta government in the Aerospace Industry Association, and that representation is continuing to grow. Alberta has recognized that it needs to divest outside of the energy sector, and as noted earlier at the beginning of this session, it's a key area of interest. And so at the moment, in addition to sponsoring academia, a large development fund has been created, and a percentage of that has been allocated to aerospace. I've been involved with the meetings at the regional level and at the government level, and there is going to be additional support for the aerospace sector in the next 5 years. So this program is very likely to grow at the university and within industry, and you're going to see an increasing focus on this.
What new companies do you think are going to be entering into the Alberta, the Calgary aerospace scene? And if they want to get involved, Craig and Artem, with the work that you're doing, what's the best way to do that?
I think so. As I mentioned before, our goal is to make sure when someone wants to do this exciting, high-speed airspace technology, they think about Alberta and they think about Calgary. So that's the goal. Now, there are so many startups, so many small SMEs, right, who are working in this area. So if they're interested in collaboration with academia, be as a part of this network, and then being a future member of the consortiums, they can simply send us an email, as Craig said, and we will continue with that. And even if it's, let's say, not my or Craig direct expertise, we have 40+ people within the network who touch base on the different aspects of the aerospace technology. Now, there is a quick answer. So many companies developing and emerging in this sector, especially autonomous vehicles, high-speed autonomous vehicles. So that's the future in my sense. So that's what I can say about that.
Thank you. We've talked a fair bit about rockets. There's other elements of it, of course. And so why don't we start with what's going on at the University of Calgary in Alberta around guidance, navigation, and control, and other elements in aerospace?
Well, there's I would say there's already existing companies, especially in Calgary, because we have the geomatics program here that is around geospatial technology. So I think Lockheed Martin CDL is a company here that does work with autonomous systems and in the geospatial area. For an autonomous system, to like say the example Arden gave, a high-speed UAV, that vehicle needs to communicate effectively over large distances, and just in terms of safety, it needs to know where it is and when it needs to safely abort and that sort of thing. So I think if Alberta became a hub for the high-speed autonomous vehicle development, high-speed radar, the communication associated with those vehicles would be the complementary companies that would have to develop here. So and strengthen here, because some of them already are working here.
And if I may, just to add a quick note on that about the industries, we are constantly looking for the new partnerships. So we are growing. We have lots of people working in different areas. So we are looking for the new partnerships, new engagement with the industries. And there are so many supportive tools on the provincial and governmental funding level to enable that collaboration. So thanks.
I can also share that as was mentioned before, it's a multidisciplinary industry. So when you're looking at navigation guidance systems and electronic systems engineering, it complements the mechanical engineering and high-speed fluid dynamic research and all kinds of disciplines that have to come together here to make this work. And because Alberta's decided to focus here and invest here in the next decade, and private industry is investing a lot here as well. We've got it's a multi-million-dollar program just even at the U of C. So you're going to see a lot of activity here, bringing all the disciplines together. It's just a new industry challenge, and it's going to require all hands on deck.
I think we could go on for quite a long time. I have time for one last question. And I'll go back. We heard about SpaceX earlier in our discussion today, and there's a question where the question is, did SpaceX succeed because it got funding very early on in the concept stage? And if yes, how can we make that happen for new ventures, new ideas here in our own backyard?
I can cover some of that. The short answer is it's complicated. SpaceX, on the one hand, it was actually a while before they got any significant government contract, so that didn't happen super early. Part of what helped them, admittedly, was the fact that their founder was a billionaire who was willing to put up the necessary funds to get them to the point of a successful flight of their Falcon 1. And really, that was the point where people started taking them more seriously. So that did come a little bit later. But what people often miss is the fact that it wasn't just this purely private approach to rocket development. There were actually a number of US government programs and policies that went a long way towards enabling SpaceX to do what they did. And I could spend a lot of time listing off what those were, but I think the important point is that there are a lot of things that governments can do to support this industry that go beyond simply, you know, shelling out money or giving contracts. The promise of contracts is a really useful thing, and one of the things that the U.S. did that was really good was their COTS program. So it stood for Commercial Orbital Transportation Services, and basically the government said, if a company can develop a private means to carry this amount of cargo to the International Space Station, we will help you to build that capability, and we will commit to buying a certain number of launches. And so there were several phases to this program, but SpaceX got in on that quite early, and that not only helped them with their development, but it also gave them something they could take to investors and say, look, if we do this, this is not speculative. The government has promised to buy a certain number of flights from us. So all of a sudden that helped their business case to close, and that goes a really, really long way. And there are many other programs and policies that they benefited from as well, including just having access to government produced IP and government research and testing facilities. So there are a lot of things that governments can do that really did go a long way to helping SpaceX.
And with that, it's time to wrap things up. If I wanted another aerospace pun, I would say something like time has flown by, but I will avoid saying that. I want to really thank all the panelists to share with us all the exciting work that's happening in the aerospace, whether it be the student teams and clubs, whether it be the new miner, the work that we're doing with rockets, with drones, with control systems. So I really want to thank Craig, Vlad, Artem, and Adam for your time here today. Before we go, I want to invite everybody to our next Schulich Connects, which will take place in January 28th. It's going to be featuring Dr. Stephen Bryant and some of the research and industry partnerships he's been doing in the future of energy research. Over 5 years, Stephen's research track record includes $10 million in funding, over 100 research leading to 4 startups, 18 inventions. It's going to be another Schulich Connects like today that you won't want to miss. Thank you everyone for joining us today, and have a wonderful day.